All right, let's talk about ATPL performance calculations. I know. They can feel pretty overwhelming. But what if I told you there's a simple logic behind all those numbers that can make everything click? Well, in this explainer, we're going to break it all down step by step. So let's jump right in with the big one, takeoff. There is one critical mistake that trips up countless students in their exams. And you know what? It all comes down to a single number. Getting this wrong could mean failing your check ride or worse. We're going to show you what it is and how to nail it every single time. We're going to cover the whole shebang, from mass imbalance to the V-speeds that dictate your every move. By the end of this, you won't just be solving problems, you'll be thinking like a seasoned pilot. So, where do we start? Well, before we even think about getting airborne, we have to master the ground game. And that all starts with the unshakable foundation of every single safe flight, mass and balance. Okay, think of this as your roadmap. It's kind of like building with Legos, right? You start with the absolute basics, the basic empty mass, or BEM. Then you add your crew to get the dry operating mass. Next up, you add the fuel, which gives you the operating mass. And finally go the passengers and cargo. That's your traffic load. See how each piece just builds on the last? All of that comes together to give you your final takeoff mass, or TOM. So now that we know our mass, we've got to find its sweet spot, the center of gravity, or CG. Just try to picture the entire aircraft perfectly balanced on a single point. That's your CG. And getting its location just right is the difference between a nice, stable flight and, well, a potential disaster. Now, instead of talking about the CG in feet or meters, we use something a little more elegant, the mean aerodynamic chord, or percent Mach. I know it sounds complex, but it's really just a clever way of standardizing the balance point relative to the wing. You can just think of it as the safe zone for your CG. And for most jets, that's going to be somewhere between 20 and 40%. So why do we care so much about the CG? Well, it's a classic trade-off. A forward CG gives you rock-solid stability, but it costs you at the pump because of all that extra drag. An aft CG, on the other hand, is way more efficient and gives you a lower stall speed, but it can be a lot less forgiving. So where would you rather be? It's all about finding that perfect balance for each and every flight. All right, our aircraft is perfectly balanced, so it's time to get it moving. But how fast should we go? This is where the language of performance really comes into play. The V-speeds. These aren't just random numbers on a dial. They are the absolute rules of the road for the sky. First up is V1. This is the big one. It's the point of no return. Before you hit this speed, if an engine fails, you hit the brakes. Simple. But the second you pass it, you are committed to the sky no matter what happens. It is without a doubt the most critical decision you'll make on that runway. Next up, we have VR, the moment of liftoff. This is that magic speed where you gently pull back on the yoke and the aircraft just lifts off. But it's not just about getting airborne. It's about doing it with enough control authority to handle any surprises. That's why it's directly tied to your minimum control speed. And once you're airborne, V2 becomes your absolute best friend. Seriously. If an engine fails after V1, this is the speed that's going to carry you safely up and over any obstacles in your path. It's not just a number, it's your lifeline. Hey, here's a little golden nugget for your exams. Ready? VRF is always 1.3 times your stall speed in the landing configuration, VS0. You need to burn that number into your brain. It's a guaranteed mark on your test and, more importantly, a critical safety margin in the real world. 1.3. Got it? Have you ever wondered why jets and props fly so differently when you're trying to be efficient? This table breaks it all down. For endurance, which is just maximum time in the air, a prop pilot is looking for minimum power, but a jet pilot, they're aiming for minimum drag. So why the difference? It all comes down to the fundamentally different ways they generate thrust. So we've got our weight figured out, we've got our speeds. Now for the million-dollar question. Do we actually have enough runway? Let's dive into the nitty-gritty of takeoff performance. I know, this flowchart for takeoff distance required, or TODR, it might look like a mad scientist's notes, but I promise you, it's actually a pretty simple 3-step process. So let's unravel it together, shall we? See? It's just a simple 3-step dance. First, you pull your gross distance right out of the performance charts. Second, you adjust that number for real-world conditions, like a wet runway or an uphill slope. And third, you add your safety factor to get the net distance. That's really all there is to it. And here it is. This is that critical mistake I mentioned earlier, the one that catches everyone out. forgetting the 1.25 safety factor. This is not just some random number. It's your get out of jail free card. Never, ever, ever forget to add this 25% buffer. It is the #1 reason people fail the performance exams. But hey, the calculations don't just stop at liftoff. The initial climb is this carefully choreographed dance of segments. You climb out at V2 until the gear is up. Then you'll level off at a minimum of 400 feet to accelerate, clean up the aircraft by retracting the flaps, and then you continue your ascent. Each and every step is designed for maximum safety and performance. So we've conquered the skies, but now comes the ultimate test of skill, the landing. Getting back on the ground safely actually requires even more precision than taking off. Does this look familiar? It should. The landing calculation is basically a mirror image of the takeoff one. We start with a gross distance, we apply our corrections, and then we add a safety margin. Why keep it so consistent? Because safety is always the name of the game. It's that same 3-step process. Get your gross distance, correct for the conditions, and then add your safety net. And for jets, listen to this. It's a whopping 1.43 factor. That gives you a 43% buffer. You can think of that as having a parachute for your parachute. So, what are the big takeaways here? First, master your mass and balance. Second, speak the language of V-speeds fluently. And third, never, ever forget your safety factors. But really, above all else, you have to understand the why behind the numbers. That's what separates a real pilot from a button pusher. You've got the theory down pat, but can you apply it when the pressure is really on? The real test isn't in the classroom. It's up there, in the cockpit, with hundreds of lives in your hands. Are you ready for that responsibility? Look, if this explainer helped you connect the dots, do me a favor and hit that subscribe button. We've got plenty more tips and tricks just like this to help you absolutely crush your ATPL exams. Thanks for watching, and as always, fly safe.